Welcome to my channel once again. This is Shatari. In today's topic, we are going to look at this titration question in the series. So the question goes this way. A is a solution containing 4.00 gram of impure ACl in 1 dm cube of solution. B is a solution containing 4 gram of sodium hydrogen trioxocarbonate in 500 centimeter cube of solution. Take 22.90 centimeter cube as total volume of acid used. This is the VA. And 25 centimeter cube as volume of base, that is the VB. We are asked to calculate 1, the concentration of B in mole per dm cube, concentration of 2, concentration of A in mole per dm cube, 3, mass of sodium ions in 1 dm cube of B, 4, percentage purity of ACl in A, 5, the volume of carbon dioxide produced from sodium trioxocarbonate 4 at STP. So you check this question, we have so many parameters to work on. In this now, what is given to us, as I've said before, the concentration of the acid and that of the base is not given to us. And we are going to use the concentration of this, the mass concentration from sodium hydrogen trioxocarbonate 4 to get the concentration of this. So we are told in this question that B is a solution containing 4 grams of sodium hydrogen trioxocarbonate 4 in 500 centimeter cube. So in this now, we must know if 4 gram of sodium trioxocarbonate 4 in 500 gram or 500 cm cube gives so. What more? What is a gram of sodium hydrogen trioxocarbonate 4 that will be dissolved in 1 dm cube? That is for us to have the mass concentration of sodium hydrogen trioxocarbonate 4. So let's solve from B now. Say from there, concentration of B in mole per dm cube. In all of this, the concentration of the acid and that of the base is not given to us. So that Ca, Va, and all over Cb, Vb equals to Na all over Nb will not be used in this aspect because this concentration of the acid and that of the base is not given to us. So we are going to derive this concentration of the base first for us to have an edge way. So let's use, we said 500 cm cube of sodium hydrogen trioxocarbonate contains 4 grams. So 500 volume of solution contains 4 grams. So that is to say, how much more is 1000? Let's know the dm cube of this substance will give us S. So we're going to solve for the mass concentration of sodium hydrogen trioxocarbonate 4 in 1 dm cube. So we're going to cross multiply so that this equation can be linear. So they're going to have 500 cm cube times S is equals to 4 gram times 1000 cm cube. So that is to say, if we should have something like this, for us to have S to be on its own, we're going to divide both sides. By what? 500. So if you should divide both sides by 500, you're going to have 500 cm cube times S all over 500 cm cube is equals to 4 gram times 1000 cm cube all over 500 cm cube. So here, this and this will cancel. Here we're going to have 4 times this, we're going to have 4000 cm cube cancel cm cube gram all over 500. 500, if we should divide this, you're going to have 8 gram per dm cube. It's already equivalent to, it's not dissolved in 1 dm cube. That is 8 gram per dm cube is dissolved in 8 gram is dissolved in 1 dm cube. That is the mass concentration of sodium hydrogen trioxocarbonate 4 is 8 gram per dm cube. So from this, we can actually work out the molarity of this base using this mass conc. So from this, let's have the molar mass of each of these acid and base. So let's solve molar mass. molar mass of A first. Let's look for the molar mass of A. The molar mass of A, which is ACl, it means that the relative atomic mass is given to us. We said hydrogen occurred how many times? Once. Where the relative atomic mass of hydrogen is 1. Plus chlorine occurred how many times in ACl? 1 times the relative atomic mass of this is 35.5. Here we have 1 plus 35.5 is equals to 36.5 gram per mole of ACl. So we are just solving this so that in case we need the molar mass in manipulating this calculation, we can actually bring it forward. So this now we'll talk about the molar mass of B, which is sodium hydrogen triazocarbonate. So here now we said the molar mass, sodium occurred how many times? Once. So the relative atomic mass of sodium is 23. 23 plus hydrogen occurred how many times? 1 times 1 plus carbon occurred how many times? 1. The relative atomic mass of carbon is 12 plus oxygen occurred 3 times relative atomic mass of oxygen is 16. So here we're going to have 23 plus 1 times 12 plus 48. Here we're going to have 84 gram per mole of sodium hydrogen triazocarbonate. So the essence of solving the molar mass of both acid and base, so that we can actually we must use one or two, must use their value in this calculation. So let me confirm this. We said 23 plus 1 plus 12 plus 48. Okay, it's 84. All right. So this now, let's look for one now. Mass conc, 1 above. Mass concentration of B in mole per dm cube. Since we already know the mass concentration of B and the molar mass of B, we can actually look for the molarity by using this relationship: mass concentration in gram per dm cube is equals to molarity in mole per dm cube times molar mass in gram per mole. So in this now, we can actually move automatically. We can move. We said the mass concentration of B is 8 gram per dm cube is equals to molarity. We're looking for molarity, which is the concentration. Molarity times molar mass of this sodium hydrogen triazocarbonate is 84 gram per mole. So for us to have this, divide both sides as well by 84 gram per mole. So we are going to have 8 gram per dm cube all over 84 gram per mole is equal to molarity times 84 gram per mole divided by 84 gram per mole. So here cancel this. So molarity of B in mole per dm cube is equals to 8 gram per dm cube all over 84 gram per mole. So gram cancel what? Gram. All right. 8 divided by 84. All right, the concentration of B mole per dm cube of B is equal to 0.095 mole per dm cube of B. All right, so this is the concentration of B. Since one of the concentration is derived now, we can look for the concentration of A, which is concentration of B is obtained. Concentration of B of the concentration of A now can be obtained by using CA, VA all over CB, BB. So we can use this. We're going to have II, concentration of A in mole per dm cube, So since the concentration of B is obtained, we can use the CA now. CA, VA all over CB, VB is equals to NA all over what? NB. Where CA, we are looking for the concentration of A. We're going to look for VB. VA is giving us the volume of acid, which is your titer value. And as I've said, is peculiar to peculiar to a student. If you are group, you can use a particular titer value in your class. So in this now, we are using 29.90 as our titer value in this calculation. We says CB is given to us as 0.095. We say VB is the volume of pipette is 25. So Na, what is Na? The mole ratio of the acid is 1. Nb is the mole ratio of the base is 1 as well. For if we should substitute the value, we are going to have Ca times 22.90 all over Cb is given as 0.095 times 25 is equals to 1 all over 1. So if we should cross multiply, let make the equation linear. First, you're going to have Ca times 22.90 times 1 is equals to 0.095 times 25 times 1. So divide both sides by 22.90 times 1. I'm going to have Ca times 22.90 times 1 all over 22.90 times 1 is equals to 0.095 times 25 times 1 all over 22.90. So this go out with this. So Ca we are going to have a 0.095 times 25 left with is equal to 22.375 divided by 22.90 divided by 22.90. So A is equal, concentration of A, which is Ca, is equal to 0.104 mole per dm cube. All right, we have been able to solve for this. So the concentration of A and B is obtained accordingly. So the next question is mass of sodium ions in 1 dm cube of B. So in this now, let's write out this concentration. So we're going to use it. B, concentration of B is equals to 0.095 mole per dm cube. Concentration of A is giving us 0.104 mole per dm cube. All right. By so doing, we can wipe this. So that is the most important parameter we needed now. So we say 3 mass of sodium ions in 1 dm cube of B. So we can use the relationship of this equation to assume the mass concentration of this. So we're talking now specifically about the sodium hydrogen trioxocarbon 4. So if we should use ionic theory, for instance, we're going to have hydrogen CO3. We're going to say this guy, when it decomposes, we're going to have hydrogen. We're going to have C3 negative. That is to say, 1 mole of this give 1 mole of sodium, hydrogen, carbon, 1 mole. So in this now, we can infer that if we should have the concentration 1 mole, so if 1 mole of this give this and give, and we are given that the mole, that means 0.095 of this compound will give 0.095 of sodium, comma 0.095 of this, 0.095 of this. So we are asked to look for this sodium ion. So we can now infer automatically this is using, we said the balanced chemical equation can give us a better information about what is happening in this chemical reaction. So with this now, we cannot infer. Since this now, the concentration of this is given, we can use a very simple equation. So let's use from the mole concept. So if you should understand the formula in mole concept, you can manipulate this calculation easily by using the 3 formula most of the time. We can use the number of moles equals to given gram mole over molar mass. Number of moles in aqueous solution, we say number of moles equals to molarity times volume all over 1000. So those are important equations in the laboratory. So in this now, let's say we have given gram, well, let's say number of moles, let's use number of moles here is equals to gram all over what? Molar mass. All over molar mass. So the number of moles here is equivalent to 0.095, which is 1 mole of this gives 1 mole of this. So if we should have 45 mil here, it gives 45 mil here as well, according to good user say. So in this now, 0.095 will give gram all over what? Molar mass of sodium is 23. Molar mass of sodium is 23. We can say gram. We say gram is equal to 0.095 times 23. So in this now, we can infer 0.095 times 23 is equal to, so mass of sodium ion is equals to 2.185 gram. Hope this is quite understood, is clear. So we are done with this. We are done with that. So yeah, we now move that mass of sodium ion, the mass that we obtain is 2.185 gram. So by so doing, we can actually look for the other values. So we say we are done with option 3. We are going for percentage purity. We can have percentage purity. Let's solve for percentage purity. So when we talk about the percentage purity, we said is the pure substance that actually react in a chemical reaction. So why the impure remain in the system. So this now, we said the volume of the impure is 4.0 grams. So we want to know the concentration of the pure, this pure substance. So since we are able to know the concentration and the molar mass, we can actually know the mass of the pure substance. So we are going to use mass conc. Mass conc is equals to molarity times molar mass. So the molar mass of the acid that is pure now, that is what we are looking for. The concentration of the acid is 0.104 times molar mass of HCl is 36.5. So mass of pure HCl will now give, we can determine the volume of the pure is the mass of the pure HCl is 0.104 times 36.5. That is to say, it's 37.95. So approximately, are going to have 3.4. No, 3.8. 3.8 gram per dm cube. Let's use. So in this now, since it's dissolved in dm cube, it's actually given that way. So in this now, we're going to have, so percentage purity, we can solve percentage purity. Percentage purity is given that mass of pure, let's bring it down. Okay, let's take it here. We can have a percentage purity of ACL now. It's given as a mass of pure ACL all over mass of impure ACL times 100. Since we're talking about percentage, is multiplied by 100. Mass of pure, we got 3.8 all over what is given to us. The impure is 4.0 times 100. So 3 divided by 8, 3.8 divided by 4 times 100. So we have the percentage purity, that is percentage purity of ACL is 95%. So this is the theoretical percentage purity in when you check the label of the label of ACL can, it's always around 96%. Yes, it's percentage purity around 96%. So in this we already obtained the purity, the concentration, the percentage purity of ACL. So in this question, we have been able to solve for A, the concentration of B, concentration of A, sodium, the mass of sodium ions, and the percentage purity of ACL is equals to 95%. 95%. So by so doing, let's move to the last aspect of the question. Let's move to the last aspect of the question. So we're going to move. Let's look for this. Okay, we are through with this percentage purity. Let's go for this. The volume of carbon dioxide produced from sodium hydrocarbonate is the same. So under the question before the titration, this is what happened during the chemical reaction. It means that 1 mole of this sodium hydrogen trioxocarbonate produces how many mole of this? 1 mole of carbon dioxide. And we said 1 mole of this gives, and in the equation, 0.095 mole of this gives how many mole of this? So if 1 mole, we have if 1 mole of sodium hydrogen trioxocarbonate gives, we said at STP, the volume of any substance is what? 22.4 dm3. Is what? As far as it is at STP, 1 mole of this gives how many volume of carbon dioxide is produced? Is 22.4 dm3. 0.4 dm3. So how much more of 0.095 mole of sodium hydrogen trioxocarbonate will give us what? Will give us S. We don't know. We don't know, because if 1 mole in the reaction from the balance equation If 1 mole of this gives 2.4 dm cube, how much more is 0.095 mole of sodium triazocarbonate 4? We don't know. It's going to give us S. So if we should make S the surgeon of formula, we're going to say S times 1. That means invariably is S is equals to 2.4 dm cube A times 0.095. So S is equal to all right, 2.4 times 0.095. So it's 2.13 dm cube. So this is the volume of carbon dioxide that is produced. Here is going to give us the same thing, because we have 1 mole here, we have 1 mole here, we have 1 mole here. So at STP, what is produced here, invariably using the equation, the mole ratio of the equation, 2.13 dm cube is produced here because it contains 1 mole. Here it contains 2.13 dm cube, and what is produced at the end, 2.13 dm cube. So understanding the chemical equation is very, very important, and manipulating what is actually happening from a balanced chemical equation makes you a good student, and ensure you before you start solving in your practical exam, make sure you understood the questions and the direction you can take to solve this. So in this aspect, we have been able, through this series of practical theory practice questions, we have been able to bring out questions that can solve for S, water crystallization. That is water crystallization. We're able to solve for water crystallization. We are able to solve for S if one of these this is with head. Can say, let's say we have ACl, we have SCl plus H sodium hydrogen triazocarbonate. You can look for this S as well. So we have solved for purity, presented purity. We can solve the concentration mole per dm cube of either A, B, gram per dm cube of either A or B. So these parameters are very important since you are dealing on hydrogen chloride, ACl, hydrochloric acid, and a carbonic family. There's a possibility of you solving for water crystallization. There's a possibility of solving for solubility as well. My next question will based on solubility. So the other one, they must tell you that you should solve for percentage purity. Thank you for watching. If you should like this video, please do it to share this video and turn on your notification bar for more updates on this channel. Thank you.